Hope all of you remember basic integration formula, standard integral part 1. I will be writing all the formula you need, standard integrals part 2, and then we start integration by parts. Okay, this session we will be discussing integration by parts, several sums on it, so that you don't have problem to start from any book and then partial fraction the same manner. Okay, so let's start. What is integration by parts? Let me explain. This is actually product rule of integration. Integration by parts means it is product rule of integration. Let u and v be two functions of x. U and v be two functions of x, then u into v dx, if we consider their product, integration will be done by assuming one of them the first function and the other one is the second function, and then use this rule u into integration of v dx minus d dx of u integration of v dx and then integration of this thing. So is there any choice of taking which one will be u or which one v? See, the common sense is we take out of these two functions, one is the first function whose derivative can be done and second function whose integration can be done. This is the basic concept. But if we use this rule, islet, which is known as islet, then it is of great help. Why? What I stands for? I stands for inverse, L stands for log function, A stands for algebraic, T stands for trigonometric, and E stands for exponential. If out of these 5 functions product of 2 are given, take the first one as the first function. I mean, which one comes first, that you take first function, and second one as second function. If you are not able to detect, if you find the second function not given, second function can be taken as 1. Okay, clear? So let us start with the simplest example. Say integrate, they have given x e to the power x. So here x is algebraic, e to the power x is exponential. So you see the order: algebraic first, exponential second. So x is the first function, e to the power x dx minus x derivative we have to do. It is in accordance with this, no? X integration e to the power x dx whole dx. It will be x e to the power x minus 1 into e to the power x dx. So this will be minus e to the power x plus a constant. This is the integration constant. Okay, so what I did there, we have taken first function as x, integrated the second function, multiplied it together, then derivative of first, integration of second, then whole integration. Like if we integrate, I am just writing it here in bracket, that integrating first function into second function. What is that? It is first function will be outside into integration of second this minus integration of what? Derivative of first multiplied by integration of second. Alright, this is the rule. Let us do few more. Suppose the integrand I have changed a bit. Previous one which we have started with x e to the power x, I am taking this one, say only log x dx. Which one is first function, which one second function? What I told, if you are not able to detect one of the function, you take one as the second function. So this we can write integration of log x into 1 dx. So log x will be the first function. 1 means it is algebraic function, no? So if you follow the Euler rule, in the Euler rule, log comes first, then algebraic. So log x multiplied by integration of dx, ddx of log x, integration of dx, then whole dx. Clear? So there it will be log x into x minus 1 into x dx. X log x minus x square by 2 plus c. Clear? Understood? Example 2. Now I am changing this part a bit. I am taking, instead of log x, I am taking say log x whole square. You think before I do anything here, how to indicate this one? Log x whole square is there. For this one also, there is no second function, no? We cannot find it. It is not given there. Log x into log x also very inconvenient, because log x derivative will be there, log x integration will be there. No one knows formula of log x integration. In fact, it is just found here. X log x minus x square by 2 plus c. If you substitute there, sum will be more difficult. More difficult. So how to simplify this? You take 1 as the first function. So this is log x whole square into 1 dx. You write log x whole square integration dx, second function, no? This is your first function and this one is the second one. So this minus integration of derivative of log x whole square integration 1 dx, whole dx is there. So there will be log x whole square into x minus its derivative you all know, 2 log x, and integration of dx is x, then whole dx. Am I correct? So this is changing to x into log x whole square minus 2 outside. This one we have just done. We have to do once more. If integration is not finished, you integrate once again. It is not finished, so we have to proceed. You write x into log x whole square minus 2 integration of dx minus log x integration 1 by x dx. isn't it? This is okay. Log x whole square dx, you understand? This is one type where only one function is given, second function you have to take as constant, you mean 1. Now how do you integrate x cos x dx? Product of two functions. You should remember the Eilert rule always. It is product of algebraic and trigonometric. Algebraic first and then trigonometric second. So which one going to be the first function? X. And another common logic is x, if we take second function, its integration x square by 2, next time it will increase, it goes on increasing. It will never be terminated.
The previous question, the second time that you integrated log x, will there not be like x log x minus x square?
Yeah, I have done that one. X log x minus x. This is correct. So here, this is correct because there is only x remaining, no? These two getting cancelled. So ddx of x.
Previous sum in the first sum of log x. Can you show that one, sir?
Which one?
We integrated just log x. Yes, sir. This one, sir. Here integration of b in the third last step. After that, going to be minus x.
Oh yes, you did not point it out. 1 by x into x. So there will be.
Yes, sir.
X log x minus dx. You must point it out when you find any difficulties, because I am trying to cover both the topics one by one, but I cannot do the mistake. No, I can do the mistake. You cannot do the mistake. Clear? X cos x minus ddx of x. Integration of cos x one into sin x dx. There will be x sin x plus cos x plus. Hope you have understood. If x cos x, x square cos x or sin x, whatever given, you will start this manner. Okay? Now let us do integration of, say, x tan inverse x. Tan inverse not taken so far. Inverse not taken, no? So this will be the first function. If we want to integrate this, tan inverse x first minus ddx of tan inverse x is what? X dx integration x square by 2. Clear? So this will be numerator, you write x square plus 1 minus 1 by x square plus 1 dx. Clear? So what you will do here, x square tan inverse x by 2 minus half, separate x square plus 1 by half into dx by x square plus 1. So there it will be this is what? Standard integral, you all know. This is minus, then minus minus plus. So there it will be isn't it? So answer is okay. So this is the integration of x tan inverse x. You try this one, e to the power x sin x dx, e to the power x cos x dx, then 3 to the power x. So these are exponential multiplied by a trigonometric function. Okay, this 6, 7 and 8. So you can follow the Euler rule only. I-L-A-T-E. Inverse, logarithmic, algebraic, trigonometric, exponential. Number 6, how to start? If you go by this rule, Euler rule, sin x will be first, e to the power x will be second. Let us take that only. What they have given, what we have learned, let us use that first. I equal to so trigonometric first, exponential second. Sin x e to the power x dx minus derivative of sin x is cos x, integration of e to the power x e to the power x, like this. Alright. So you have started with e to the power x sin x. Now you got e to the power x cos x dx back. It will not work. Am I correct? So what you have to do there, no formula for CBSE board, but for JEE definitely you can use the formula. We'll do that also, I'll tell you. But let us finish it first. We need not use formula for board. You do not use, I'll tell that. Use the method e to the power x minus, again you take e to the power x first, cos x integration is sin e to the power x sin x, sorry, that cos x you are integrating, no? So it will be e to the power x cos x. E to the power x cos x first, so sin x, there it will be sin x only. Please check. Cos x, e to the power x cos x you are doing, e to the power x first. Cos x integration is sin x. Okay? Acha, one thing, this e to the power x is the first function, e to the power x is the second function. So suddenly we cannot change it here. We have to proceed the same manner. Okay? So here suddenly I was taking this one first, this, no, it cannot be done. Here you have to use the same rule. Cos x first, e to the power x dx, then minus e to the power cos x. It will be minus sin x, e to the power x integration e to the power x. So I equal to plus e to the power x sin x dx, plus no, it will be minus, check. Minus minus already plus is there. This minus, so it will be minus.
Oh.
Clear? Done? So this what you have started with, you got it back.
So that is I.
So I will be this minus I. So 2i is e to the power x sin x minus cos x. Therefore, clear? Done? This is the thing. E to the power x by 2 sin x minus cos x plus c. For this particular sum, if you have changed, you are taking say sin x at second and e to the power x first, in both the cases, there will be no problem. Same answer will be there. Okay? So you practice e to the power x cos x before I move to this one. Finish it first. E to the power x cos x. Just for practice. Do this one by using the same method, e to the power x cos x dx. Which one to be taken as first, you decide, and I told you any one of them can be taken as first, any one as the second. Okay? For particularly this form. Done. Now check with my calculation. E to the power x cos x. See, I have followed the rule here. I have taken sin x first, e to the power x second. I am changing it here to show you that for this particular type, you take any one of them first, the other one second, there will be no difference. So I am taking e to the power x first, cos x dx minus cos x integration is sin x dx. So e to the power x sin x minus, again by parts for it, integration of sin x is minus cos x minus integration of so this will be e to the power x minus same answer, there will be no difference. E to the power x cos x dx value is this. Now take this one on the left side. Plus Okay, so this implies 2 into sin x plus cos x. So this thing will be this divided by 2 plus c e to the power x cos x dx e to the power x into sin x plus cos x, that divided by 2. 2 is the answer. This is the answer. So if you take e to the power x second and cos x, that by following the Eilert rule, you can check afterwards whether you are getting different answers or not. It will be the same answer. There is no difference. Okay. Now let us go for doing this type, 3 to the power x sin x dx. Number 8. Three to the power x sin x dx. 3 to the power x is also of the form e to the power x. I mean, like that only, constant to the power a variable. So start the same manner, take any one of them first, it doesn't matter, same answer will be there. So start this way, let I equal to 3 to the power x sin x dx. I am taking this one first, like previous one. Sin x integration is minus cos x minus derivative of 3 to the power x, 3 to the power x log 3. Clear? Check, check. It's correct. I have taken this and then integrated by parts. 3 to the power x derivative is 3 to the power x log 3. Sin x integration is minus cos x. It has become plus. Or I equal to plus. It's by parts once more. 3 to the power x first function cos x integration is sin x minus derivative of 3 to the power x, I mean integration of derivative of this thing, integration of this thing dx. Okay. So same integrand you got back on the right hand side. You have started with this I. Here you got it back. You just simplify it. 3 to the power x. I am taking this and this together. 3 to the power x is common. Sin x into log 3 minus cos x minus log 3 whole square (3 to the power x sin x dx). Okay. So I equal to minus log 3 whole square into I. This thing is I. What we have started with, left hand side it was 3 to the power x sin x only. So now take the whole thing on left side. 1 plus so I finally will take this form. I equal to what? Sin x into log 3 minus cos x. This is the final answer. Okay? For 3 to the power x multiplied by sin x, this is the answer. So these are all by direct formula. No substitution, nothing is required. But sometimes we need to substitute and then integrate by parts. Sometimes integrands have a very special form. So that I am going to state here. Integration of the type e to the power x fx plus f dot x. Okay? If the integrand is of this form, directly we will be writing the answer, that is e to the power x fx plus c. Direct. But automatically you will ask me why the integrand will be of this form, e to the power x into fx. It is because if we use by parts for left side, this is equal to e to the power x fx dx isn't it? Just expressed as sum of two integrands. Now keep this thing unchanged. I mean, if you take fx as first function, fx first, integration into the power x dx minus derivative of fx e to the power x is e to the power x dx plus so it will be fx e to the power x answer plus c, so e to the power x fx plus c. Clear? Hope you have understood. But if you face this kind of problem in board paper, you cannot write the answer only unless you have mentioned which one fx and which one f dash x. You won't get any marks. I am telling you today. So learn it and apply it. Evaluate the following integrands. Let's start with the easiest one. Acha, wait a minute. Change a bit. E to the power x into log x plus 1 by x. If you follow the method I have used there, you will definitely get the answer. But this is a standard integral. That form only NCERT has mentioned. So you can use the form directly by mentioning which one fx, which one f dash x. See how am I writing the answer here for a descriptive paper? Let fx equal to log x. So f dash x is what? 1 by x. So this is fx and this is f dash x. What will be their answer? The answer, as you mentioned, which one fx, which one f dash x, answer will be e to the power x log x plus c. You just mention it. Which one fx, Which one? F dash x. You try once. Problem number 2, I am asking you to apply this method where it is of the form e to the power x into fx plus f dash x. Like, I have another one ready with me, just you solve it. X by x plus 1 whole square. I am writing many sums. Let me find it. Is it done by all of you? You write it this manner. Your aim is to express fx plus f dash x. So write e to the power x, then separate. Not a difficult sum. Let fx equal to 1 by x. Okay. So which one fx, which one f dash x identified? Answer will be, am I clear? Hope you have understood. Solve 2 more. This form is very important, that's why we must do it properly. Let's see if you can do it or not. Take time. Can you express these two sums in the form fx plus f dash x? You just look at the previous sum, the way I did it, by some mental manipulation. We got it. So here, is it possible for this sum to get fx plus f dash x? It is of course possible. So what you will do there, you write have I written correctly? So this will be e to the power x into 1 minus okay. Now what? Can I express like previous one, x by x plus 1 whole square? This you never forget. Many sums can be made from this type. So you write it as sum of two integrands. You recognize the second integrand. Hope you remember this form. I have done just now. Do it. Isn't it? Now separate. Write x plus 1 by x plus 1 whole square, 1 by x plus 1 whole square dx. So what is the answer over there then? What is the answer over there? If you have taken this one fx, this part f dash x. So answer will be e to the power x minus 2 into, in exam you just show which one fx, which one f dash x and write the answer. Don't hesitate. Okay? You understand? I explain once more. This x square plus 1 you write x plus 1 whole square minus 2x by x plus 1 whole square. Now what you did there, separate this by this minus this by this. This by this is 1, you can see. I have written minus 2x by x plus 1 whole square. We have to try. So when x e to the power x all these involved, we will remember this manipulation again and again. So here we did the same thing. Split this one as sum of two integrands, minus 2 outside, use x plus 1 minus 1 in the numerator and x plus 1 whole square here, then separate and then find which one fx, which one f dash x. If you take fx equal to 1 by x plus 1, then am I correct? Done? Go for next one. E to the power x 1 minus sin x by 1 minus cos x. Try. Should try first, then only I will do. Sum is here. E to the power x into 1 minus sin x by 1 minus cos x dx. Okay. So what to do here? Again e to the power x into fx plus f dash x. We will express that form. Little bit of trigo manipulation will be of great help here. Okay. So you write it this manner: 1 minus, and this is 2 sin square x by 2 dx. Now this by this, just separate. This divided by this, half cosec square x by 2 minus cot x by 2 dx. Am I correct? Have I done correctly? Yes, just separation, nothing else. So to apply that e to the power x fx plus f dash x form, we just detect that part. It's quite obvious that if we have taken this one fx, this part is f dash x. You agree or not? With minus cot x by 2 derivative is half cosec square x by 2. So what will be the answer? So minus e to the power x cot x by 2 is the answer. Clear? Understood? Now there are some by parts problem where substitution is inevitable. We need to use substitution, then proceed. I am telling you the most famous sum in this category here, that is sin inverse x by 1 minus x square to the power 3 by 2. Such a big function, it cannot be done with comfort, isn't it? We have to think what can be done. Should I take sin inverse x first and this one second? Huge problem. If you take this one second, then no one knows the formula. If it is 1 minus x to the power 3 by 2, I can write the answer. But it is 1 minus x squared to the power 3 by 2. No, never think that manner. So better for this sum, put now check what is coming there. Put x equal to sine theta. Sine inverse x, what to write? Sine inverse x is theta. So given integrand, if you have taken this one I going to be what? Theta cos theta d theta, that divided by 1 minus sine square theta whole to the power 3 by 2. One minus sine square is what? Cos square to the power 3 by 2. It will be, I hope you can complete the sum. Theta into 1 by cos square theta, that is sec square theta into theta d theta. Now what? Now how to complete the sum? It has come theta into sec square theta d theta. Go by parts. Which one to be first, which one to be second? Sec square theta can be integrated. Take that as second. Theta can be differentiated nicely. So take theta as the first one and complete the sum. Before I do it here. Sec square theta integration, it will be tan theta. Okay. Minus tan theta integration is log of sec theta plus c. Clear? Understood? Now go for this kind of problem. How do you manipulate? This is this class, I mean right now I'm just giving you different types of sums from by parts. So if you practice with me, it will not give you trouble in future. So x minus sin x by 1 minus cos x. How to proceed? How to proceed? Any idea? Just write okay, done. Now what? Separate and integrate. Separate and enjoy integration. X into half this minus cot x by 2 dx. You just separate, sine get cancelled, cos by sine it is cot x by 2. So it's an ordinary sum, not a difficult one. So what we will do here, you take half common, cosec square x by 2 dx minus cot x by 2, how will you write? log of sine of x by 2 that divided by 1 by 2. Okay? Wait a minute, because this integration sign should not be there, no? Oh, no, it is there, sorry. It is there. We have just integrated second one. This one you have to use by parts. So, you have to use by parts here. Sorry, by mistake I have used the ink. So, use by parts for it. X first, cosec square x by 2 is what? By 1 by 2, and this one 2 log sine x by 2 plus c. Wait a minute. One more step we have to go. So x, this thing minus integration of 1 cot x by 2 by 1 by 2, isn't it? Cosec square integration minus cot x by 2 by 1 by 2 dx minus 2 log sine x by 2. So this is half this one we have to do again. 2 outside, integration cot x by 2 dx. Not a problem. Minus 2 log sine x by 2. Actually, this also just 2 get cancelled. Minus x cot x by 2 plus cot x by 2. What's the integration? Cot x by 2. So is it getting cancelled? Check once. I think it's getting cancelled. If it is not, you should check. Check it once. X minus sin x by 1 minus cos x. Plus c. I hope it is correct. Just check. Is it okay? Can you see the board? Bas. Do. Finish it. Answer is minus x cot x by 2 plus c. Hope you have understood. I am writing another problem. Then I will tell you integration by parts part 2. Some more standard integral. But before that, you need to do a sum like this. Sin log x by x cube dx. If required, don't hesitate to make a substitution. Is okay? Sin log x by x cube. But at the same time, if we substitute, then variable may be changed in such a manner that it is not integrable. So be careful when you are making substitution there. So let log x equal to z. So if you differentiate, 1 by x dx should be dz, isn't it? So now the integrand, it will be what? Sin log x, 1x you got here, but x square is remaining. X square into x dx. That's why you are going to write sin z dx by x is dz, and the value of x is e to the power 2z, because x square. From here you write x, no base is there means exponential base, it is e to the power z. So it's square e to the power 2z. Now it is of the form which we have done today. It is of what form? E to the power minus 2z sin z dz. Go by parts. And you have to use by parts twice. Clear? I am not completing the sum here. Instead, I will be discussing the formula, some more standard integral from here. Previous chapter, you did standard integral. This is some more standard integrals. Some more standard integral, let me write all those one by one. Root over x square plus a square dx is x square plus a square by 2 plus a square by 2 log of x plus this plus c. Did you understand? Do you remember it? You don't remember, you are doing it first time. So I'll tell you to derive the result if possible before I do it. And let me write all the standard integrals formula here. It is root over x square plus a square, minus sign is there, minus, it is minus. Okay? Done? I can give you the formula for root over a square minus x square also. Just wait. Okay? X square plus a square given, x square minus, oh my god, this will be minus. All a square will be changed by minus a square, nothing else. So you got two formula over there. What is the second one? X root over a square minus x square by 2 plus a square by 2 sin inverse x by a plus c. Okay? But before we apply it, we need to prove. How to prove it? Then I'll show you the application. Proof. For first one, no second function. So we'll be taking 1 as the second function. Isn't it? Root x square plus a square. First, 1 is the second. Its integration is x. Now derivative of this thing is what? ddx of this is what? Half. Isn't it? This to get cancelled. So it will be x square by, am I correct? The integrand was root x square plus a square dx, isn't it? That you have written 1 dx, and that by using by parts you have reached another very difficult form, because I is this, it has become very big, but it is not actually so. Why? I am just showing you here. Integration x squared dx by, what will you get here? So this by this is root over a square dx by root over x square plus a square. Alright? So answer will be x root minus a square into I. Please check. Check once. Except the last step. Check. Root over x square plus a square is what? This I you have started with. I, and dx by root over x square plus a square is a standard integral, you know. What is its value? Log of. So take it there. Write it there. It is a square log of x plus. Now finally by putting it there we will get the answer. Remember this form? Integration of this part is what? Finally I minus isn't it? So now here we have started with I equal to this has become x root x square plus a square minus I square log of x plus root over x square plus a square. So this I you take left hand side, 2I equal to plus a square log of so I equal to log of x plus so this only was required. We have derived the formula. Formula is correct. Now let us apply it in solving sums like this. Say it is under root x square minus 3x minus 2 dx. I did not prove the second one. Second one is also can be done by the same method. So there is no need to derive the formula. One, I told you it's fine. Obviously you have the curiosity that how does it come before application. That's why I told you. Try next one. I mean this one I will not derive. This one. This sum. Under root x square minus 3x minus 2. For this, the way we used standard integral, I will be finding which form is there out of these three, then apply it. So this you go by method of completing square. This you can do here. X square 2x 3 by 2, 9 by 4. So this is what? X minus 3 by 2 whole square minus 17 by 4. Isn't it? So this will be under root check. This is okay. Now which form is this? X has no coefficient. Root over x square minus x square form. So this you write x, in place of x there is x minus 3 by 2. Minus e square by 2 log of the same thing, that is x minus three by 2 whole square simplification is yours. Clear? Understood? Let us take one more sum from here, that is going to take the form a square minus x square. The second problem, you take under root two x minus x square dx. How to do it? 2x minus x square dx. Again go by method of completing square. Completing square, you must be very good. You must be very good on class 9-10 topic, isn't it? This you can write and add a square over there, add a square here also, isn't it? So this is what? Under root a square minus x square form. X minus a can be treated as x only. So what is its answer? X root over plus a square by 2 sine inverse. This is the formula. I did not derive. This you can try at home. We have used this formula. Root over a square minus x square is what? X root a square minus x square by 2 plus a square by 2 sine inverse x by a plus c. Clear? That form only is being used. In place of x, there is x minus a, that we have used. Sum number 3 in this category, say we have a problem like this. X plus a root over x square minus b square dx. Not a difficult sum. Just think x plus a multiplied by root over x square minus b square. You first think. Can you solve? You just separate this integrand, you write in the form x into root over x square minus b square dx isn't it? This one is the chapter 2 sum, substitution. This one we have just done, root over x square minus a square. Here you put two x dx equal to 2z dz. So x dx equal to z dz. Okay, and so let us simplify it first. Root over z square. No, not root over z square. X square minus b square is z square. So z and x dx you will write z dz. X dx I have written. So root over x square minus b square, this I have written first. It's correct. This will be z dz z cube by 3 so this you write. How will you write this? The second part, x root over x square minus b square by 2 plus or minus b square by 2 So it will be z square. Oh, sorry. Z square will be z cube by 3. That I have written. Clear? So sum of these two will tell you the answer. Now, before we leave integration by parts, two excellent sums I would like to discuss with you. Two very good sums. Like 2 or 3. Like quickly you try to solve this one. And then this one, and then this one, and then just sin log x, only sin log x. Okay, I'm writing here. How to do? This one how to do? I am showing you. Rationalize x plus root over x square minus 1, isn't it? So integration of x dx x square by 2 plus a square by 2. No, it will be minus. Don't do this mistake. Root x square minus a square. No. I hope you have understood. Finished? Okay? Not a difficult one. After rationalization, don't think that is a first chapter sum. This sum is suitable for discussion of the formula root over x square minus a square. How do you think about the next one? Sin log x plus cos log x. How do you do? You think, then I'll do. It's a very easy sum. But how to? Manipulate. Make a substitution. Let log x equal to z. So 1 by x dx equal to dz sin z cos z Do you understand what we are getting there? E to the power x fx plus f dash x. If this one fz, this is f dash z. So value is e to the power z sin z plus c. Put the value of z over there. It will be what? E to the power log x sin of log x plus c. Okay? Answer is this. E to the power log x you can write, you can simplify, no? E to the power log x is what? X sin log x plus c. Then this one like previous one only. You take log x equal to z. So this will be changed to what? Sin z e to the power z dz. This you can do. We have done this type today. Okay? Hope you are able to start integration by parts at home now after this session.